Welcome back to Cyvid, where we embark on an enthralling journey into the realm of physics and the dynamics of motion. Today, we present an engrossing subject for your intellectual indulgence, deconstructing the influence of friction on motion. It may escape your notice, but friction exerts a profound and consequential influence on the trajectories and interactions of objects within our quotidian existence. In the forthcoming discourse, we shall plunge into the intricate science of friction and dissect its profound ramifications on the kinematics of movement. In the realm of our daily existence, the often underestimated force of friction takes center stage, dictating the course of progress and innovation. Unraveling the intricate tapestry of our world, the science of friction and motion delves into this fundamental force, exploring its origins, properties, and the multifaceted ways it shapes our reality. In our relentless pursuit of technological advancement, the comprehension and utilization of friction emerge as paramount. Yet, this vital force is frequently disregarded. Friction, the silent resistance opposing the relative motion between two surfaces in contact, pervades our everyday experiences. It manifests itself in the microscopic irregularities adorning the surfaces of objects, where interlocking intricacies obstruct motion and give rise to this formidable force. The dichotomy of friction unfolds in two distinct forms, static and kinetic. Static friction acts as a staunch sentinel, preventing the movement of an object under applied force, while kinetic friction opposes the motion of an object in contact with a surface. These phenomena find their roots in the complex interplay of materials' nature, the pressing force, and the roughness of surfaces. A pivotal concept in the realm of friction lies in the coefficient of friction, quantifying the intricate interaction between materials. Throughout the annals of time, the enigma of friction has captivated the minds of scholars. Ancient civilizations, such as Egypt, harnessed this knowledge to construct awe-inspiring edifices like the pyramids. The echoes of curiosity persisted through the ages, finding resonance in the meticulous experiments of Leonardo da Vinci during the Renaissance. His pioneering endeavors laid the groundwork for the systematic exploration of friction, a path further illuminated by the contributions of luminaries like Robert Hooke and Guillaume Amontons in the subsequent centuries. The evolution of friction study led to the birth of tribology, a discipline dedicated to unraveling the mysteries of friction, lubrication, and wear. Amidst the burgeoning machinery of the Industrial Revolution, friction emerged as a vital area of inquiry, shaping the landscape of technology and innovation. Friction, an intricate force, manifests in diverse forms within our daily lives. Dry friction, the commonplace resistance between solid surfaces devoid of lubrication, ensures your car clings to the road and your shoes grip slippery terrains. Fluid friction, encountered as objects traverse mediums like air or water, is pivotal in realms such as aviation and maritime transport. Rolling friction, inherent when objects roll over surfaces, offers efficiency crucial for transportation and machinery. At a microscopic level, internal friction governs the behavior of materials under stress, influencing elasticity and plasticity. Static friction maintains stability, ensuring objects do not slide off surfaces under applied force. Understanding these nuanced forms of friction proves indispensable, unveiling the intricate mechanics that govern our world. Friction's influence extends beyond the realm of man-made systems. It is, in fact, an inherent force in the natural world. Let us embark on a journey through which we shall explore how diverse life forms and natural occurrences have harnessed the formidable power of friction. One gecko's remarkable limbs, these astonishing creatures have evolved a distinctive method for adhering to various surfaces. The gecko's feet employ millions of minuscule bristles, known as setae, to establish adhesion through the subtle influence of van der Waals forces. We shall unravel the scientific intricacies of gecko feet and the contemporary applications they inspire. To the art of ice skating, the seemingly enchanting act of effortlessly gliding upon ice hinges on the adept management of friction. We will delve into the mechanisms that enable ice skates to minimize friction, granting skaters the grace to glide with consummate ease. 3. The ascent of climbing plants. Many botanical specimens exhibit the ability to ascend vertical walls or structures. This feat is achieved by exercising precise control over the friction between their climbing appendages and the supporting surface. An in-depth understanding of this phenomenon can serve as a wellspring of inspiration for novel advancements in materials and technology. 4. The poetry of animal locomotion. From the graceful sprint of a cheetah to the sinuous slithering of a snake, animals have undergone evolutionary adaptations that are finely tuned to their environments, often entailing the optimization of friction. We shall undertake a comprehensive exploration of the multifarious modes of animal locomotion and the pivotal role of friction in each. 5. The microcosm of insect adhesion. Insects such as ants and beetles demonstrate the remarkable ability to traverse walls and ceilings with effortless dexterity. Their diminutive adhesive structures and minuscule hair-like structures play a pivotal role in creating adhesion and deftly managing friction. By delving into the intricacies of these natural exemplars, we stand to gain invaluable insights that can be transposed into the realms of robotics, materials science, and diverse industries. Nature has, time and again, devised ingenious methods to harness and manipulate friction, and our comprehension of these mechanisms can precipitate a veritable cornucopia of thrilling innovations. Friction is not merely a pragmatic concept, it constitutes a bona fide domain of study replete with mathematical principles and formulae devised to delineate and prognosticate its behaviors. Let us embark on an exploration of the mathematical underpinnings that underpin the phenomena of friction. 1. Coulomb's frictional doctrine. Bearing the moniker of Charles Augustin de Coulomb, this fundamental edict serves to quantify the frictional forces at play when two objects come into contact. We shall embark on an expedition through the equation and its multifarious applications that extend across the spectrum of physics and engineering. 2. The laws of Amontons. Guillaume Amontons bequeathed invaluable contributions to the realm of friction, encapsulating his insights within a series of laws pertaining to the nuanced behaviors of friction under diverse conditions. Our voyage will encompass a comprehensive exploration of Amontons' laws and their salience in unraveling the complexities of friction. 3. The coefficient of friction. In order to ascribe quantitative values to the friction encountered between materials, engineers and scientists employ the coefficient of friction. We shall engage in a discourse that delineates how this coefficient varies with different material pairings and how its determination is empirically established. 4. The generation of frictional heat. As objects interact through friction, they engender heat as a byproduct. This phenomenon carries profound applications in the design of critical systems such as brakes and clutches. We shall expound upon the mathematical underpinnings governing the generation of frictional heat. 5. Frictional forces on inclined planes. When we confront the dynamic of objects navigating inclined planes, friction emerges as a pivotal factor that either sustains or impedes motion. Our trajectory will encompass the mathematical formulae that are employed to calculate the forces in play on inclined surfaces. Upon completion of this odyssey, you shall possess a firm grasp of the mathematical tools and principles requisite for the analysis of friction. These equations and laws are of inestimable import to engineers, physicists, and all those who endeavor to fathom and wield friction within a panoply of applications. In the realm of engineering and technology, the enigmatic force known as friction can be a double-edged sword, both aiding and obstructing progress. We shall embark on an exploration of how engineers and visionaries have harnessed the enigmatic power of friction, as well as their unwavering quest to conquer its inherent limitations. 1. Lubrication. Among the most prevalent techniques employed to mitigate the relentless grip of friction are the applications of lubricants. We shall embark on a journey through the intricacies of lubrication, unraveling the scientific marvels of various lubricants employed across diverse domains, from engines to manufacturing processes. 2. Bearings and bushings. Within the intricate world of rotating machinery, mechanical components known as bearings and bushings emerge as saviors, diligently striving to minimize the relentless forces of friction. We shall engage in a discourse on the artistry of their design and the fundamental principles governing their operation, recognizing their indispensable role across an array of industries. 3. Roller coasters and thrill rides. The amusement park's adrenaline-pumping marvels thrive on the art of manipulating and controlling friction to deliver exhilarating experiences. We shall embark on an electrifying odyssey, unraveling the science behind roller coasters and the ingenious techniques employed by engineers to craft heart-pounding thrills. 4. Aerospace engineering. The aerospace industry stands as a pinnacle of innovation, where the battle against friction takes center stage to ensure unparalleled efficiency and safety. We shall delve into the domain of aerospace engineering, delving deep into the relentless challenges posed by friction in the realms of aircraft design and celestial exploration. 5. High-speed rail. The blazing locomotives hurtling across high-speed rails confront formidable friction, a nemesis leading to wear and energy dissipation. We shall unveil the pioneering advancements in high-speed rail technology, aimed at taming the relentless forces of friction and enhancing efficiency. The domains of engineering and technology perpetually nudge the boundaries of possibility, wielding an astute understanding of, and at times, a masterful manipulation of, friction. Mechanical systems teem with opportunities for friction to exert its compelling influence. We shall embark on a quest to uncover the pivotal role played by friction across a multitude of mechanical systems. 1. Gears and gearboxes. Gears, the unsung heroes of numerous mechanical systems, are not exempt from the clutches of friction. We shall scrutinize the intricate dance between gears and friction, as engineers sculpt gearboxes with precision to optimize their performance. 2. Brakes and clutches. Within the intricacies of motion control, friction reigns supreme, shaping the functionalities of brakes and clutches. Our exploration will lead us to fathom the intricate science underpinning these systems, elucidating their profound role in motion regulation and safety assurance. 3. Bearings and rotational motion. Beyond merely combating friction, bearings hold the key to the realm of seamless rotational motion. We shall journey through the universe of bearings, from the humble ball bearings to the resilient roller bearings, delving into their manifold applications. 4. Cams and followers. Cams, the mechanical alchemists converting rotary motion into the mesmerizing world of reciprocation, dance to the tune of friction. We shall scrutinize the influence of friction on cam follower systems and their intricate design. 5. Vibration damping. In the intricate symphony of mechanical systems, friction emerges as a versatile maestro, orchestrating the dampening of vibrations. Our odyssey shall lead us to uncover the ingenious use of friction to quell unwelcome oscillations, thus preserving stability in a myriad of machines. An intimate understanding of the convoluted interplay of friction within these mechanical systems stands as an imperative creed for engineers and designers. By artfully optimizing friction, they breathe life into more efficient and dependable machinery. Friction's influence extends far beyond the solid surfaces we encounter daily and extends its grasp into the fluid realm, manifesting as the intriguing dynamics of viscosity and drag. Let us embark on a journey to unravel the enigmatic intricacies of these fluid phenomena. 1. Dynamic viscosity and kinematic viscosity. Viscosity, a property denoting a fluid's resistance to flow, is an integral aspect of fluid dynamics. We shall delve deep into the distinct domains of dynamic and kinematic viscosity, exploring their paramount roles across diverse fields, including the automotive and pharmaceutical industries. 2. The enigmatic drag force. When an object traverses a fluid medium, it confronts drag force, a manifestation of friction's presence. Here, we shall delve into the myriad factors that conspire to shape drag force, its profound implications for vehicular dynamics, and the tireless efforts of engineers to mitigate it in pursuit of enhanced efficiency. 3. The chaotic ballet of turbulence. Turbulent flow is a realm characterized by the mesmerizing dance of chaotic and irregular fluid motion. We shall journey into the heart of this captivating turbulence, scrutinizing the pivotal role played by friction in its inception and its far-reaching consequences in fields as diverse as aeronautics and meteorology. 4. The enigma of Reynolds number. The Reynolds number, a dimensionless parameter, serves as a harbinger that predicts the transition of a fluid's flow regime. We shall embark on a voyage through the intricate science of the Reynolds number, understanding how engineers employ this enigmatic numeral to fathom when friction emerges as a dominant force within the intricacies of fluid dynamics. 5. The veil of boundary layers. Proximity to solid surfaces gives rise to boundary layers, where the influence of friction is most pronounced. Within this obscurity, we shall explore the multifaceted impact of boundary layers on phenomena such as heat transfer, aerodynamics, and the optimization of various systems, unlocking the secrets that lay hidden beneath this veil. Fluid dynamics stands as a labyrinthine domain, adorned with practical applications of profound complexity. Mastering the subtleties of how friction orchestrates its ballet within the fluidic realm is a prerequisite for refining the designs of objects as diverse as aircraft and pipelines. Friction, an influential force, wields power over not just motion but also exercises a pivotal role in the domains of heat and energy transference. We embark on a journey to unravel the intricate synergy between perplexity and burstiness, exemplified by the union of friction and these foundational thermodynamic phenomena. 1. The realm of thermal friction. As two entities engage in the act of mutual abrasion, a notable byproduct arises in the form of heat, a direct consequence of frictional discord. Herein, we embark upon a profound exploration of thermal friction, scrutinizing its far-reaching implications across diverse applications, spanning from the intricacies of braking systems to the art of fine-tuning cutting tools. 2. The artistry of heat conduction. The minuscule skirmishes at the atomic scale, influenced by the forces of friction, wield an enduring influence over the orchestration of thermal energy transference within solid materials. In this segment, we embark on an odyssey into the labyrinthine world of friction's microcosmic realm, discerning the profound impact it imparts upon the dynamic conduction of thermal energy within materials that manifest varying frictional characteristics. 3. Harnessing the Seebeck effect. Within the annals of thermoelectricity, a select category of materials exhibits the remarkable ability to metamorphose heat into electrical vitality, a phenomenon rooted in the enigmatic Seebeck effect. We embark upon an expedition to fathom the manner in which meticulous manipulation of friction at the submicroscopic level serves as the linchpin, elevating the efficiency quotient of these remarkable thermoelectric materials. 4. The enigma of energy dissipation. Within the mechanized realms, the ubiquitous presence of friction engenders the inevitable loss of energy. In this discourse, we unravel the intricate mechanisms underlying energy dissipation, expounding upon the artful strategies devised by engineers to ameliorate these wasteful losses. Furthermore, we shall elucidate the pivotal role played by friction in the trajectory toward crafting more energy-efficient technological marvels. 5. The innovations of friction stir welding.